Okay guys, another great video by your favorite teacher. So first off, you guys did awesome on TCD. All the grades were really high. So good job on that. Hope everything's going good. Hope you're all safe. So today we got test val. It's going to be a lot of fun. So it's pretty easy. We're just going to basically be learning how to set up the chi-square, which is what all this stuff is about. So we'll learn how to set that thing up, how to work through all your problems. There usually are like 10 to 15 of these on the registry. So let's learn how to set them up, work them out. Like I said, it's pretty easy stuff. You're not going to have to actually calculate the actual percentage. You'll just have to know how to set it up. So that's your answer is going to be this number divided by this number plus this number. It may just end up being this number divided by this number. But you don't have to be able to calculate 67% or anything like that. It's going to be pretty basic stuff. So I got our little lecture pulled up here on my trusty computer. Hopefully it works for everybody. If it doesn't work for everybody, shoot me an email. Let me know. And I will post it back in the PDF or whatever. Well, I don't know why it didn't work last time. But anyways, let's get through this PowerPoint deal. We'll read through it. And then we'll set up this chi-square on the little example here at the back. So starting with test val, it's taken years to prove that ultrasound technology alone is accurate in the assessment of vascular disease. What's changed? Technology, and we've gotten better. Ultrasound technology that is safe and reliable when used by well-trained sonographers in a department that is focused on quality assurance. Quality assurance refers to a program for the systematic monitoring and evaluation and various aspects of vascular testing to ensure that the standards of quality are being met. So in other words, how well are we doing the tests that we do? To achieve this confidence, as ultrasound profession rely on statistics to demonstrate the effectiveness of imaging and Doppler in the assessment of vascular disease. The science of making effective use of numerical data relating to the groups of individuals or experiments is called statistics. Statistics concerns the gathering of facts. Facts are usually accumulated as numbers are presented to show certain information. For example, it is not scientific to simply say you have a busy schedule or a department unless you can back that up with numbers of studies and how many vascular specialists are available to perform them. So, when your boss calls and asks if you're busy or too busy to add something on, you can't just say you're busy. You have to say, yeah, well, there's only 2 of us here and we have 25 scans to do today, and it's already past lunchtime. So, that's an example of a statistic. It is also not scientific to say that your laboratory or department has a high rate of accuracy unless that can be backed up with facts. How many cerebrovascular studies that your lab performed were proved right or wrong? How do you determine whether your studies were correct? What system is available to help you determine the accuracy of your lab? We all want to say we are 100% accurate all the time. Is that doable? How do we assess the quality of our work and the reliability of our diagnostic exams? We use quality assurance. So gold standard is a term used to compare one form of a newer diagnostic test with another that is well established and reliable testing parameter. Gold standard in vascular imaging is angiography, CTA, MRA, or surgical findings. Venograms are kind of outdated now. So ultrasound's not the gold standard at the moment, but the better we get, the closer we are to getting there. Reliability is the consistency of obtaining similar results in similar circumstances. A laboratory or ultrasound department is considered reliable when the results of the test that are produced are consistently correct when compared to the gold standard. Accuracy. Accuracy is the ability to give the right answer. That is, accuracy in finding disease when disease is present and not finding disease when there is no disease present by our gold standard. The more tests you perform that agree with the gold standard, in this case the arteriogram, the greater the accuracy. On the other hand, the more studies that disagree with the gold standard, the greater the difference between the expected, which is what we are, and the observed, which is the gold standard, and the poorer our accuracy is going to be. So the chi-square is designed as a box containing 4 letters, A through D. Each represents results of the expected and of the observed findings. Our tests are going to be the non-invasive or the expected, and the arteriogram is the gold standard or what is observed. So you go to the next one and you got your little box like this. You got A, B, C, D. And that's what we're calling our chi-square. So how do we fill the little boxes out? So box A is going to be our true positive. So with a true positive, both the non-invasive test, which is RN, the expected, and the arteriogram, which is the observed, both agree. Tests were both positive / they show a disease. So we find a DVT, they do the gold standard test, they find a DVT. So we both agree that they're both positive, so it is a true positive. So that goes into A. So going into the B is the false positive. The non-invasive test indicated the study was positive. So we do a test, we say it's positive, but the arteriogram, which is the gold standard, indicated that it was negative. So we said there's stenosis, but the angio found that it was normal. So we had a false positive. Okay? So then into box C is the false negative. The non-invasive study showed that the study was negative. So we said that it was negative, but the arteriogram showed it was positive. So that is going to be a false negative. Okay? Basically, we're saying there's no DVT. The venogram shows that there's a DVT. So, falsely negative. Box D is the true negative. So, with true negative, both the non-invasive and the gold standard agree that the study was negative. So, we do a carotid, show no stenosis. They do an arteriogram, no stenosis. Both of us agree that it's negative, so it is a true negative. So here's a little example question, which we're not going to fill it out right now. Let's get through all this stuff and then we'll go to this chi-square thing. 140 patients had non-invasive and invasive venous studies. So 68 of the non-invasive, which is us, and the invasive, which is them, indicate acute DVT. So 68 of them are true positive, while 54 show no evidence. So 68 true positive, 54 true negatives. Okay? So that's our step one, is to ask ourselves the true positives and the true negatives. So in 12 of the cases, the non-invasive studies, which is us, were negative, but the gold standard showed that they were positive. So that would be a false negative, because we said that it was negative, but they were actually positive. Then 6 of the non-invasive studies were positive, but the venograms were negative. So that would be the false positive, because we said that they were positive, but they were actually negative. Okay? So that's our second step. So find the false negatives, find the false positives. Okay, sensitivity is the ability of a test to detect disease when present. We calculate this by the true positive divided by all of the gold standard positive diagnosis. So we've got our true positives plus our false negatives. Specificity is the ability to identify normality, no disease, negative results. We find this by the true negatives divided by all of the gold standard negative diagnosis. So we got true negatives divided by true negative plus false positive. Okay? None of this makes sense right now until we actually get it on the square, and then it's not going to be that bad. So there's the next slide, just the calculations on sensitivity, specificity, positive predictive value, the PPV. So percentage of non-invasive tests result that accurately predict abnormality. So this is all of our positive tests that are showing abnormality or positive. So that's going to be our true positives divided by true positives plus false positives. The NPV is basically the same thing, but all of the negative stuff. So it's the percentage of non-invasive test results that accurately predict normality. So this is our true negatives divided by our true negatives plus our false negatives. Okay? Accuracy, again, that's the ability to give the right answer. So accuracy in finding disease when disease is present, which is a true positive, and not finding disease when there is no disease present, which is a true negative, divided by all the results. So true positive plus true negative divided by true positive plus false positive plus false negative plus true negative. Okay? So here's our case study where let's start filling this thing out. Okay? So does this show up? Yes. Okay. So this is our chi-square. True positive, false positive, false negative, true negative. Okay? So, looking at this thing, this is how we're going to get our sensitivity. True positive and the false negative. Okay? We're going to get our specificity by the true negative divided by true negative plus false positive. The PPV is all of our positive stuff. The negative NPV is going this way. So it's our true negative over true negative, false negative. Okay? So, how are we going to remember how to fill this thing out? This is our A, B, C, D. So we're going to put sensitivity in this corner with an arrow going down. Then we're going to put specificity in this corner with the arrow going up. So these are going to be the numbers, the direction of the flow. The PPV is going to go positive this way. You remember the positives always go on top, the negatives go on the bottoms. So think of negative being below 0. So your negatives are always going to go on the bottom part. The positives are going to go on the top part. So think of the top ends with a P for positive. Okay, so positive numbers up here, negative numbers down there. Sensitivity goes this way, specificity goes that way, the NPV goes this way, and the PPV goes that way. Okay? Everybody good and confused? Let's fill one out. How about it? Okay, so let's just go off this little example that we have right here. So, the vascular lab has a cerebral angiograms to document the status of 70 patients. So, that's 140 ICAs, right? Because we have 2 of those. Of the 140 vessels studied, 90 arteriograms confirmed the normal findings. So, 90 normal. So that would be a true negative. Our true negative goes in this bottom one right here. Okay? So then, 45 confirmed abnormal findings. So that is a true positive. True positive goes in this corner right here. True positive, true negative. Okay? 5 disagree. Don't worry about the 5. That's just the number that's going to throw you guys off. So 3 angios found no disease. So that's going to be a false positive. So that's going to go this one right here. And then 2 found disease. So that is going to be the false negative. Okay? And that one's going to go right there. So when we set everything up, true positive, false positive, false negative, and true negative. Okay? I don't know if that's showing up on the right way of y'all. It's not on mine. So, that's how we're going to set up our chi-square. So, sensitivity. How do we get sensitivity? Sensitivity is the true positive divided by true positive plus false negative. So, that's going to be 45 divided by 47. Okay? Because you got 45 divided by 45 plus 2. It's going this way. Okay? It's easy as that. That's all you're going to have to know. So, specificity. How do we get our specificity? We're going true negative and divided by true negative and false positive. So, that is going to be 90 divided by 90 plus 3. Going this way. Okay? So it's 90 over 93. Accuracy. So accuracy, remember, is all of them. Okay? So, we're looking for true positive plus true negative. This one right there. True positive, true negative, divided by true positive plus false negative plus true negative. So, all that worked out is going to be this one plus all of them. So basically you've got 135 over 140. All of the ICAs looked at, right? There's that. Okay. Positive PPV. So the PPV is our top going this way. So that one's going to be 45 over 48. Okay? 45 divided by 45 plus 3. 48. Okay? NPV is negative going this way. Okay? So that's going to be 90 divided by 90 plus 2. Okay? That's how we do our chi-square. That's literally it. So, they're going to give you a word problem on your registry, and it's going to read something like that example. So I'm just going to click back over there. So it's going to basically read the same way. You got 70 patients, 140 ICAs were looked at. 90 were normal, 45 were abnormal. And you just have to decipher what's your true positive, what's your true negative, what's your false positive, what's your false negative. Okay? Just get all that stuff together, put it in your box. Remember this thing right here. Burn that into your minds. Okay? That is all you need to know to be able to do your registries. And from there on, all you gotta do is put the numbers in the right spot. And that's it. Okay? I feel like we've got another one on here. Okay, yeah, we do. So, let me find this one I got set up somewhere. I think it's over here. Yep. Okay. So, 80 patients with suspected DVT underwent non-invasive venous studies. Okay. 36 of the non-invasive and invasive revealed no evidence, while 24 non-invasive and invasive tests demonstrated the presence of DVT. So, we have 24 that are positive. True positives. Okay? Then you've got 36 that reveal no thrombus. So 36 is going to be our true negative. In 11 patients, the venous compression ultrasounds were positive, but the venograms were negative. So we said they were positive, but they're not, so that would be a false positive. 9 patients, the venograms were positive, while the non-invasive revealed no DVT. So, excuse me. That is, we said it was negative, but it was actually positive. So that's going to be a false negative. Okay? Nope. Okay, so I thought there's another slide, but there's not. So, let's set this thing up, shall we? So, this is a little one. I think you can see it a little bit better. So we got 24 false positives,